So I want you to look at this problem with me, and it says a banana bread recipe calls for 1.5 cups of sugar and 3/4 cup of oil. How many total cups of oil and sugar are used in the recipe? And so right now, what we're doing is we're thinking about if we have oil and sugar, and the word "and" insinuates that we're going to put those together. We're mixing those together, right? So if we want to find the total, that means we're adding. Would you agree?
Yes.
Okay. I realize some people are trying to get others off task, but that's not in your best interest. So you need to make sure that you are doing what's best for you, not what somebody else is trying to entice you to do. Okay? So I'm going to draw a picture right now of a hole and another picture, and I'm going to cut this one in half, and I'm very quickly going to shade 1.5, and I'm going to call that the sugar amount. And then we've got our oil. So I'm going to go ahead and draw another hole. And we're going to cut this into fourths. And how much of that do you think I'm going to need to shade? 3/4. So part of the reason why I wanted to draw these pictures right now is because this is a good time to talk about, do we have equal or unequal pieces? Case. Huh? We have unequal pieces. And when we have unequal pieces, there are only two actions. We can either add or we can subtract. So Hope, when I think about finding a total, when I think about combining the oil and the sugar in the recipe, are we adding or are we subtracting? We're adding. The equation is writing a number sentence without an equal sign. Garrett, if you feel like you want to move to the floor, you are more than welcome. So we have 1 and 1/2, and we're putting that with 3/4. And so thinking about Monday's lesson, we have to have like place values, we have to have like pieces to put them together. Do we have those like pieces right now? No. So off to the side, I'm going to slowly think about the smaller denominator name, and can I count by 2s to get to 4?
Yes.
So over to the side, I'm just going to write that, 2, 4. It takes me 2 groups of 2 to get to the number 4. So that means I can multiply the bottom by 4 and the top by 4. And I'm going to rename this whole amount. The 1 slides down, and 1, I'm so sorry, I wrote the wrong number. This should be 1, 2. We're going to multiply by 2 here. Multiply by 2. Very sorry, but I guess if you're truly listening to this video, you'll make that change. And now I can rename it. So 2 times 2 is going to give you 4, and 2 times 1 is going to give you 2. That makes way more sense. And we're going to slide the plus and the 3/4 down, because there was no need to change 3/4. So now that we have all fourths, can we put all the fourths together?
Yes.
Yes. So what's 2/4 plus 3/4 going to give you, Liam?
5/4.
5/4. And 1 plus nothing is just going to give you 1. So tell me what you notice about this fraction. Avery.
That there's a number of the numerator is bigger than the denominator, so it needs to transform into one whole.
That's right. So when we have a larger numerator than a denominator, we call that an improper fraction because it doesn't look proper. proper would be smaller numerator than denominator, right? So here's how we're going to handle this. What makes a whole? Does anybody know? What makes a whole, Leah?
If the numerator and the denominator are the same.
That's exactly right. So we're going to say a whole is worth 4/4. And here's how we're going to handle that. 4/4 is a whole. So we're basically going to take this whole and we're going to add it to the other whole. Now how many wholes do we have? 2 wholes. If I started with 5/4 and I took away 4/4 to make that whole, how many fourths are left, Finley?
3/4.
5/4 minus 4/4. No. 5 minus 4. 1/4. And there's your answer. Right? Now, what's tricky about that is this whole number and this regrouping business. That's kind of tricky. I realize that. So maybe when we think about our number line, we might iron out some of those details. So the first thing I want you to do is just draw as straight of a line as you possibly can. And in your neatest, best writing, give it 2 endpoints. And I'm going to start this number line at 0. And as I look at my answer, I know I cannot go past 3. So 3 is going to be my endpoint here. Now what I want to do is I want to partition this so that I have a 1 and a 2. And I noticed that my common denominator was 4. So I'm going to partition each whole into 4 equal parts. The easiest way to do that is to split it in half first. Call those your halves. 1 1/2, 2 1/2. Then split each half again. So that would be your 1/4, your 1/2, your 3/4, your 1 whole, your 1 1/4, your 1 1/2, your 1 3/4, your 2, your 2 1/4, your 2 1/2, and your 2 3/4. That makes good sense here. Now what I'm going to choose to do on the top is write the improper equivalent. The improper equivalent is going to look the same on the top and the bottom until I get to the number 1. So we have 1/4, we have 2/4, we have 3/4, and then we have 4/4. That all looks the same, right? But if I continued adding 4s, wouldn't this be 5/4? What comes after 5/4? 6/4, 7/4, 8/4. Hey, quick question. What's 8 divided by 4 going to give you?
4.
Oh, there's my whole number 2. What's going to come after 8/4? 9/4, 10/4, 11/4, 12/4. And I'm basically going to create a situation kind of like what we were looking at in class on Monday. I'm going to grab a quick highlighter. On Monday, when we were doing some problems, we were looking at a number line that was already labeled for us. But if I were going to look at this, I would start at 0, and I'm going to go all the way to the number 1. Could just shade that in, and then 2 more fourths. I'm stopping right there. So there's my 1 2/4. I'm adding that to 3/4, so I have 3 more fourths. 1 2 3. Gonna pick it up. 1, 2, 3. And there's my stopping point. What did I end up stopping on? Yes.
9 4.
Or
2 and 1 4.
2 and 1 4. So some of you may be thinking, well, Miss Barlow, how do we know that 9/4 is the same as 2 and 1/4? And I'm going to tell you. When you have a whole, how many fourths is that? Yes. 4 fourths. We have one whole, 4 fourths. Yes. We have another whole, 4 fourths. Yes. That takes care of my whole number 2, right? Plus an extra fourth. What's 4 plus 4 plus 9, plus 1 gonna give you? Yeah.
9/4.
It's gonna give you 9/4. Well, wait a minute. Aren't those the same thing?
Yes.
So does that make sense now?
Yeah.
So it should all make sense. So I just wanted you to be aware that for every number that is a mixed number, because we call these mixed numbers when we have a whole number and a fraction put together, there is an equivalent improper fraction. You end up using a lot of improper fractions in like junior high and high school to like help you manipulate numbers easily. But you can learn more about that next year.